In this section we need to know the specific heat capacity and the thermal capacity. The specific heat capacity is the amount of thermal energy needed to raise the temperature of a mass of 1 kilogram of a substance by 1 Kelvin. And we use the symbol C for the capacity, specific heat capacity. So, it depends on the amount of thermal energy. If it needs a lot of thermal energy to raise the temperature, it's going to have a high specific heat capacity. So it's the thermal energy per kilogram per difference of 1 Kelvin. So it's delta Q divided by m delta T. We usually put it in the following format, where delta Q is equal to mc delta T. The specific heat capacity is a description of how much thermal energy it can store. The bigger the specific heat capacity, the more it can store, the more thermal energy it can store for every kilogram and for every difference of 1 Kelvin. Delta Q is equal to mc delta T. Delta Q is the thermal energy transferred in joules, or lost. M is the mass in kilograms. C is the specific heat capacity. And delta T is the change in temperature. It can be in Kelvin, it can be degrees centigrade. They are the same size. And then we need to look at thermal capacity, and this is a slight change of this formula, but without the reference to the mass. So if you have a lot of the substance, it's going to have a high thermal capacity, because it will need a lot of thermal energy to make it heat up. So we have this new term, which is the thermal capacity, which is the amount of thermal energy needed to raise the temperature of a mass of a substance by 1 Kelvin. So there's no reference to the mass here. So the thermal capacity, in this case C, is very large if the mass is very large. So, specific heat capacity question. Delta Q is equal to mc delta T. These are the terms. So what is happening here? As the thermal energy increases, the kinetic energy of the molecules increases. In other words, the temperature rises. So the thermal energy causes an increase in temperature. Let's look at some specific heat capacities. In joules per degree per kilogram. For example, an important number is the specific heat capacity of water is 4,186 joules per Kelvin per kilogram. Ice is 2,100. Steam is 2,010. Aluminium is about 900. Iron is about 450. So which of these substances will be the hardest to heat up? Well, it has to be the water, because it needs 4,000 joules for 1 kilogram to go up by 1 degree centigrade. Iron is easy to heat up. It has a low specific heat capacity. It only needs 450 joules per kilogram per Kelvin. Here we have an example. Nicholas Cheep wants to calculate what heat is needed to raise 1.5 litres, in other words 1.5 kilograms of water by 5 degrees centigrade. Can you help him? Using delta Q is equal to mc delta T. You want to find out the heat. Do you know the mass? It's 1.5. Do you know C? It's 4,186. Do you know the temperature change? The change is 5 degrees. So you end up with a value of 31,000 joules, I believe. What is the change in temperature of 512 grams of iron if it absorbs 817 joules of thermal energy? The specific heat capacity of iron is 450 joules per degree per Kelvin. So So you need to find the change in temperature. So you need to take this equation and isolate for delta T. So divide both sides by MC. Here we have an exam style question, an easy exam question, but they like to ask questions of this nature. A student drops a cold block of metal, which is at 20 degrees, into a hot mug, which is 0.5 kilograms of tea, which is at 90 degrees centigrade. After a few minutes, the water and metal are at the same temperature in thermal equilibrium, and they are both at 80 degrees centigrade or Celsius. Find the mass of the metal. The specific heat capacity of water is 4,200 joules per kilogram per Kelvin. The specific heat capacity of the metal is 450 joules per kilogram per Kelvin. How can we do this? A big clue. You have to use the conservation of energy. What happens in this example is that the cold block gains some thermal energy. Where does it gain the energy from? From the hot water. And basically, the thermal energy lost by the water will be the thermal energy gained by the metal block. So the energy lost by the water is the thermal energy gained by the metal block. A more challenging question would be 0.5 kilograms of water at 100 degrees. The specific heat capacity is 4,200 joules per Kelvin per kilogram. Drop in 0.22 kilograms of metal at 20 degrees and find the final temperature.